I'm starting the Okay, so we're here. Do you guys remember on the project we did before Thanksgiving? What's a reflection? Yeah, it flipped across. And so this one, see how it, so we're flipping across the x-axis. You always have to read what you're flipping across. So this is our x-axis. So first thing I'm going to do, because we're talking about coordinates here where we don't always have to graph it, but we can find coordinates. Can I have a volunteer tell me what are the coordinates of point A? Do we need to review? Yeah, which one's negative? Negative 3, 4. And so I start at the origin and I count x first, which is negative 3, and then the 4 to the A. Okay, and then how about B? 4, 2. How about C? 3, 8, or is it 7? 2, 3, 4, 5. It's 7. 3, 7. Okay, and then if we just use what we did before Thanksgiving and just plot the across y-axis, just means that I count exact. So like B is up to, I just come down to across that x-axis and come my new B point. If you don't already know, the new points are always the ones marked with the little like apostrophe. So B apostrophe means that that's the new one after the reflection. A, instead of up 4, it just comes down 4. So see how I'm just counting from the x-axis just in a straight line what's up. So C was up 7 that we already counted. So we just come down 7. And then I connect them. And I check to make sure that what I graphed looks logical, like I've just flipped it over. All right, so what are the new coordinates of A? I'll count them out and find them. Negative 3 and negative 4, right? So see how my negative 3 stayed the same, right? I just, instead of going up 4, I'm just reflecting it down 4. So without counting it out, what do you think B is going to be? 4, negative 2, because all that changes, that y coordinate went down instead of up. And C? 3 and negative 7. So if we were to write the pattern, what would our pattern be? Right here. And so x is the same, y changes signs. If I was to write this in format, my x, y point would go to x and negative y. So all that's happening is you just change the sign of the y if we're reflecting over x-axis. Why do you think we're going through like to figure out the rules for the patterns here? Could you save yourself a lot of time if you just know the pattern and you don't have to like graph it all out and count it? Yeah. So that's what we're doing this time, because you guys did reflections in middle school, and so you already know how to like graph it out and stuff, but we're just trying to find the patterns so that we can find the coordinates really easily. Okay, so if we reflect across the y-axis, before we do anything, anyone want to guess what that pattern might be? Yeah, so you think it's going to be, which one do you think is going to stay the same now, x or y? Yeah, because the y would stay the same because we're going straight across, and x would change. So let's label our points first. So what is my coordinates of my x? 2, 4, both positive. How about y? Yes, 6, 2. And z? 2, negative 5. Okay. And so then if I graph my new x, I'm just going straight across the y-axis this time. So to this direction, my new x is to that direction. Z comes to this direction. Y, instead of being positive 6, becomes negative 6. Does it look like I've done it correctly? Okay. And so my new x, like you guys told me before, which one stays the same, the x or the y? Yeah, so y is going to stay the same. I'm still at positive 4. I'm still at positive 2. I'm still at negative 5. And then x changes the sign. And so our pattern is y stays the same, x changes sign. When we reflect across the line, we just have to say, from the origin, how are we getting to each point? So first, let's go ahead and label each point. So what would you label point R? Should I call in someone or volunteer? What did you say? 4 and 6, and is one of those negative? Yeah. Negative 4 and 6. So we count negative 4 this way, up 6 to get R. How about S? Negative 1, 2. How about T? Negative 6 and negative 1. Okay, so if I just look at this, if I'm reflecting across the this line, y equals x, what's my new drawing going to look like? Yeah, it's going to be flipped diagonally this way, right? And so we could, it's kind of hard to tell, but I could try to guess at what's exactly out from here, come my diagonal and say, okay, that's 1 diagonal square and a half, come 1 diagonal square and a half, and come here. So I can count diagonals, or I'm going to show you the pattern in a minute. But let's try, if we do our R1, so if I'm just counting my diagonal, so 1, 2, 3, 4, 5 is exactly 5 diagonally. 1, 2, 3, 4, 5. Does that seem like a logical flip? Oh, you guys can't see. I'm sorry. Okay, let's use my pen again. Okay, and then if I do T is 1, 2 and a half, so I do the half, and then 1, 2. And then if I connect them all, does that look correct? Yeah, it looked like I did it. So that's one way to do it. If you're going to spend all the time to like graph it out and stuff, just remember if we're doing it over a line, you have to count those just diagonally across each square. This one is much easier just to remember the pattern. So what is our new coordinates for R? Can someone count those out for me? Okay, so I heard 2, negative 1, that's for S, right? So 2, negative 1, I heard, yeah, R was 6, negative 4, and then T. Okay, so what's our pattern here? Here's switch. So for most people, this is just easier. If we're going y equals x, we just x and y change places. And so xy goes to yx. And sometimes we might have one where like you're reflecting over y equals negative x line. And same thing, just count your diagonals, figure it out if you have something like that. So once you have this, flip over to the next page. And at the top of that next page there is a summary of all the rules. So if you've forgotten them or you didn't understand your notes, it does tell you here. So if we're reflected across x-axis, then we just change that y-coordinate. If we're reflected across y-axis, you just change the x-coordinate. If it's y equals x, then you just change the order of them. And if we have that, we didn't graph it out, but if we had a y equals negative x, then you change them and make them both negative, because we're reflecting over a negative line. Okay, who knows what a line of symmetry is?
Is a line between.
Yeah, so it just means it cuts it into equal halves, right? So line of symmetry, should we write that down? Yes, no? And so it's just going to be exactly the same. You don't have, if you really know what it is, you don't have to write it down. And so if we look back at the figures that we graphed here, so once I did my reflection, what's my line of symmetry in example 1? Well, and what do we call this line here? Yeah, so it's just the line I reflected over would be my line of symmetry, right? I could fold them over on top. What's my line of symmetry for example 2? My y-axis. How about example 3? What's my line of symmetry? Yeah, y equals x is this line, because if we fold it over. So lines of symmetry is saying where can we fold it in half and the halves equal each other perfectly. And so what you're going to do right here with your group, I'll do the first one together. Where can I draw a line of symmetry for example A? Yeah, straight down the center in between the eyes, because then the two halves would be equal. And so each of the rest of these you're going to take just a minute in your group, or do it on your own and then compare answers to your group. See how many lines of symmetry you can draw for each of these. Okay? Okay, so on this one then we have the next two, which are corner to corner. So on lines of symmetry, we're just looking for, hey, where could we fold it in half and it to be right on top of each other. And then my last one, can I get a volunteer for number F? Example F. What did you say? It doesn't have any. There's no possible way I can fold that in half and have the two halves be straight on top of each other. And so this one had 4. Okay, so that is the end of our notes.